Interstellar visitors' path through the solar system. The schematic diagram of our solar system shows the dramatic path of a 2017U1- line as it crossed the plane of the planets known as the ecliptic, and then turned and headed back out. The inset shows the object's path through the inner solar system, with the short solid segment showing the small 2-week-long portion of the path during which the object can be observed by large telescopes. For comparison, the highly elongated orbit of a comet, which is part of our solar system, is also depicted. Credit Brookspace SOEST Publication Services or Institute for Astronomy. High-res JPG, high-res PDF, high-res JPG with black background. A small, recently discovered asteroid or perhaps a comet appears to have originated from outside the solar system, coming from somewhere else in our galaxy. If so, it would be the first interstellar object to be observed and confirmed by astronomers. This unusual object, for now designated a 2017U1, is less than a quarter mile 400 meters in diameter and is moving remarkably fast. Astronomers are urgently working to point telescopes around the world and in space at this notable object. Once these data are obtained and analyzed, astronomers may know more about the origin and possibly the composition of the object. A 2017U1 was discovered October 19 by the University of Hawaii's Pinstairs-1 telescope on Haleakala during the course of its nightly search for near-Earth objects for NASA. Rob Warwick, a postdoctoral researcher at the University of Hawaii Institute for Astronomy IFA, was first to identify the moving object and submit it to the Minor Planet Center. Warwick subsequently searched the Pinstairs image archive and found it was present in images taken the previous night but was not initially identified by the moving object processing. Warwick immediately realized this was an unusual object. Its motion could not be explained using either a normal solar system asteroid or comet orbit, he said. Warwick contacted IFA graduate Marco Micheli, who had the same realization using his own follow-up images taken at the European Space Agency's telescope on Tenerife in the Canary Islands. But with the combined data, everything made sense. Said Warwick, this object came from outside our solar system. This is the most extreme orbit I have ever seen, said Davide Farnocchia, a scientist at NASA's Center for Near-Earth Object Studies CNEOS at the agency's Jet Propulsion Laboratory in Pasadena, California. It is going extremely fast and on such a trajectory that we can say with confidence that this object is on its way out of the solar system and not coming back. The CNEOS team plotted the object's current trajectory and even looked into its future. A 2017U1 came from the direction of the constellation Lyra, cruising through interstellar space at a brisk clip of 15.8 miles (25.5 kilometers per second). The object approached our solar system from almost directly above the ecliptic, the plane in space near where the planets and most asteroids orbit the Sun, so it did not have any close encounters with the 8 major planets during its plunge toward the Sun. On September 2, the small body crossed under the ecliptic just inside of Mercury's orbit and then made its closest approach to the Sun on September 9. Pulled by the Sun's gravity, the object made a hairpin turn under our solar system, passing below Earth's orbit on October 14 at a distance of about 15 million miles (24 million kilometers), about 60 times the distance to the Moon. It has now shot back up above the plane of the planets and traveling at 27 miles per second (44 kilometers per second). With respect to the Sun, the object is speeding toward the constellation Pegasus. We have long suspected that these objects should exist, because during the process of planet formation a lot of material should be ejected from planetary systems. What's most surprising is that we've never seen interstellar objects pass through before, said Karen Meach, an astronomer at the IFA specializing in small bodies and their connection to solar system formation. The small body has been assigned the temporary designation A2017U1 by the Minor Planet Center (MPC) in Cambridge, Massachusetts, where all observations on small bodies in our solar system and now those just passing through are collected. Said MPC Director Matt Hallman, this kind of discovery demonstrates the great scientific value of continual wide-field surveys of the sky, coupled with intensive follow-up observations, to find things we wouldn't otherwise know are there. Since this is the first object of its type ever discovered, rules for naming this type of object will need to be established by the International Astronomical Union. We have been waiting for this day for decades, said CNEOS manager Paul Chodas. It's long been theorized that such objects exist, asteroids or comets moving around between the stars and occasionally passing through our solar system, but this is the first such detection. So far, everything indicates this is likely an interstellar object, but more data would help to confirm it. Animation showing the path of A2017U1 through the solar system. Credit NASA JPL. The Pinstairs 1 Observatory on Haleakala, Maui, opens at sunset to begin a night of mapping the sky. Credit photo by Rob Rutkowski. High-resolution TIFF NASA press releases at https://www.nasa.gov. Feature Small asteroid or comet visits from beyond the solar system. More information about asteroids and near-Earth objects can be found at the Center for Neo Studies. JPL's Asteroid Watch. NASA's Planetary Defense Coordination Office for asteroid and comet news and updates. Follow Asteroid Watch on Twitter. More information about the Pinstairs project can be found at the Pinstairs project website http://pinstairs.ifa.hawaii.edu. The Pinstairs Data Access Portal is at http://pinstairs.stsci.edu. The Panoramic Survey Telescope and Rapid Response System. Pinstairs is a wide-field survey observatory operated by the University of Hawaii Institute for Astronomy. The Minor Planets Center is hosted by the Harvard-Smithsonian Center for Astrophysics and is a sub-node of the Planetary Data System Small Bodies Node at the University of Maryland. http://www.minorplanetcenter.net. JPL hosts the Center for Near-Earth Object Studies (CNEOS). All are projects of NASA's Near-Earth Object Observations Program, and elements of the agency's Planetary Defense Coordination Office within NASA's Science Mission Directorate. Founded in 1967, the Institute for Astronomy at the University of Hawaii at Manoa conducts research into galaxies, cosmology, stars, planets, and the Sun. Its faculty and staff are also involved in astronomy education, deep space missions, and in the development and management of the observatories on Haleakala and Mauna Kea. The institute operates facilities on the islands of Oahu, Maui, and Hawaii.